Hi, this is Colin. Before we wrap up and look at application insights, I wanted to quickly cover infrastructure as code using Terraform. Let's go over to Visual Studio. Now under the env-tf folder for Terraform, I have a couple of folders here. There's a state folder and a scripts folder, which are really used just to set up Terraform to store state and run scripts. The actual infrastructure is specified in the other folders. So we've got three major components: the web app, a SQL database, and application insights. Let's look at the web app. In that folder, I have a main.tf script. This is the main script that specifies the configuration for my web application. At the top, I'm using a reference to get the connection string to both my SQL as well as application insights. I have a section of locals for setting up local variables. And then I have a resource called Azure RM Resource Group, which is going to create or validate that we have a resource group. The name is a variable that gets passed into the script so that I can reuse this for different environments. You can see a list of tags that I've specified here so that I tag my resources. This is great for governance and billing. Once I have a resource group, I'll specify an app service plan, which includes the tier and the size. Next is the web app itself. This is also going to specify the application settings like the slot name and the environment, the connection string, as well as tags. Finally, I have a slot where I specify settings for the blue slot where we did our A/B testing to. I won't take you through the other scripts for SQL and App Insights, but they're similar in structure. From these scripts, we're able to run Terraform plan, which will look at our scripts and look at the target environment and tell us exactly which actions Terraform would have to apply onto our resources to get our resources to match the script and configuration that we've supplied. From there, we could have a separate approval if we needed to before we apply that plan. In my pipeline, I do plan and apply as a single step, mostly just for demo purposes. Let's turn our attention back to App Insights. Let's start where we use custom telemetry. In this case, in my shopping cart controller, I have an add to cart method. When a user clicks add to cart on an item, this is the method that gets called. I'm setting a start time so that I can measure how long saving this operation to the database takes. I'm then getting the cart from the database, adding the product to the cart, and saving those changes. The next bit of code is where I'm adding the telemetry measures and dimensions that I want to track. This elapsed milliseconds is going to give the date difference or time difference from this point of code back to the start time. I'm also adding the price in. That's how I was able to calculate the sum of price from a set of telemetry in the Azure dashboard. I also want some properties like product category and product that I can slice and dice by. And finally, I'm calling the track event method on my telemetry provider. The name of that event is cart server add, and I'm passing in the properties and measurements for that particular telemetry event. Now this is custom telemetry. I don't need to actually do this to get a whole lot of telemetry from Application Insights by just adding it to my project. Application Insights will track every dependency call to other APIs or databases. It'll track every HTTP request coming in, any exceptions, as well as performance time, how long it took to serve the request. However, this custom telemetry gives me some extra insight into my application with application context, not just performance information. I'm going to click on the Unity config. This runs when the application starts up to register concrete implementations for interfaces. Don't worry too much about that. The important thing here is that I have an iTelemetry provider. I'm instantiating an instance of that telemetry provider called App Insights Telemetry Provider. I'm also injecting the getTelemetryProperties method. This is where I set environment, slot name, and version, so that those are dimensions on every single telemetry event that gets sent to Application Insights. Finally, let's look at the startup method. For the startup method, I'm calling the instrumentation key property to set the instrumentation key from my web config. This allows me to use a different resource for different environments as a sink for my telemetry if I choose to do so. Let's look at the class that implements this telemetry provider. This is in a separate project which is brought in as a NuGet package via Azure Artifacts. This is just a very simple wrapper around the App Insights telemetry class itself. You can see the constructor is taking in the properties that I want to add into the context so that they're sent up for every telemetry invocation. The other methods, track event, as well as track trace and track exception, just call their corresponding counterparts on the App Insights telemetry class itself. Let's go back to the Azure portal. If I click on this Open Chart and Analytics blade from my widget, that'll open up the App Insights Analytics blade for me. And here I can see the query that I used to create this widget. On the left-hand side, you can see sources that I have. One of these sources is custom events. This is where all my custom telemetry is sent to. Now there are properties that come out the box for custom telemetry, such as client type and model and OS, for tracking client information. There's also custom dimensions and custom measurements, which are JSON documents. In this query, I'm parsing out the custom dimensions.environment and custom dimensions.version property so that I can slice and dice by those properties. Wow, we covered a lot in those demos. I purposefully went a mile wide and an inch deep to give you an experience for what you could be doing end-to-end in a DevOps workflow. We started by planning and tracking in boards. We did our development in Git and used the power of GitHub to fuel our review with pull requests. We then had Dependabot and SEML scan our application and our code to ensure that we didn't have any vulnerabilities and made sure that we are secure so that we can deploy with confidence. We saw a quick example of a GitHub workflow to post a message to a Slack channel. We saw a comprehensive build, test, and package pipeline using Azure Pipelines that included managing technical debt in SonarQube. We went over how to use Terraform to specify the infrastructure that we need as code. We referenced secrets that were stored in the key vault so that we don't have to store secrets in our source code. We then used web apps to host our application and deployed our database to Azure SQL. We then used Traffic Manager and web app deployment slots to do canary testing on our application. Finally, we looked at how to monitor our application using application insights. Hopefully this has given you a good overview of what a particular DevOps workflow using GitHub, Azure DevOps, and Azure would look like. It's been fun for me. I hope you enjoyed it. Bye.